Hey guys, David here and welcome back to the series where I show you how you can build your own custom keyboards. In this video we are going to finally have a look at the hardware. How do you build a case for it that doesn't just look nice but fits all of the keys perfectly, includes stabilizers, and in the end makes it look like a proper finished keyboard product. Now before we get into the video, I want to give a big thanks to PCBWay for sponsoring this series. They make super high quality PCBs for the very affordable price, and you can get up to 10 by 10 centimeters, 10 pieces, double-sided silk screen, everything for just $5. Or if you're using my coupon code for $5 off down below, then you will get your first order completely for free. All you have to do is pay shipping. This means that you can get your very first keyboards made completely for free, which is quite amazing. So make sure to go check out PCBWay, link down below. Now, if you haven't seen the past two videos in this series, there I went over all the electronics, how you need to wire up the switches, and then in the second one, more detailed on how to integrate the controller into your PCB, which means that you can create perfect PCBs that don't need any extra lumps on the side and will make your keyboard work functionally. But now you have a fancy PCB, you have nice switches, but you need something to put them in, as just switches on a bare PCB is kinda lame. There are quite a few different approaches to keyboard enclosures. There are the very basic ones where you're using switches that have the extra pins on the side, so the 5-pin switches. Those you can solder directly to the PCB and don't really need much of a case. You can just have a simple shell on the back that protects the electronics, and you can have a mostly open keyboard design. But I feel like the much more popular option is to have some sort of key plate where the switches go through and then you solder the PCB on from the back side. This will also allow you to more easily integrate things like stabilizers for your spacebar, your shift keys, things like that. But still, there are the various options there as well. You can either have the entire front of the case be one solid piece of either aluminum or a 3D printed plastic or whatever else you want, and then have a simple backing, or you can have just a plate of metal where you put the switches through and then have a different material for the rest of the case. But what does stay true generally is that the thickness of that plate should be around 2 mm for almost all of the common switches, since that is the distance between the top of the switch where it should meet the plate and the little prongs that make sure that the switch doesn't fall out. This is also quite nice as at 2 mm things like metal are plenty sturdy, but even plastic is fairly sturdy enough at 2 mm that it won't go flexing all over the place. At the same time, it's also not super thick, so you don't have like a super heavy keyboard, which you might want, but you also might not want. But to show you a bit more detailed how to design the key plate and all of the different aspects of the enclosure, let's go over to the computer where I can more easily visualize this in Fusion. Now before we get started in Fusion 360, let's cover some terminology. In keyboard building, one of the really common things that you'll run across is units, or just U, which refers to a more simplified way of talking about the size of different keycaps. A standard keycap is defined as 1 by 1 units, and a unit is 19 mm standard. Now, if you have like a laptop keyboard or something smaller, then you might have a different size, but for mechanical keyboards, generally speaking, 1 unit equals 19 mm. So all of the regular keys are just 1 unit, but for example, the tab key here on an ANSI layer is 1.5 units, and then the caps lock might be 1.75. And all of these, you can find like these layouts for your specific layout, be it ANSI, ISO, or whatever custom layout that you want, and you can find the size of the different units. And this is also a good place to mention that keyboard layouts vary greatly. Yes, of course, like the American ANSI layout versus the European ISO layout, but even within the ANSI layout, like some of them, like this one here, have all the same size, all 1.25 U keys on the bottom, whereas some other layouts might have a 1.5 key followed by 1 key by 1.5 key. So even the spacebar, there are different sizes. 6.25 is a very common size, but there are also different sizes. So if you already know what kind of keycaps you will be using, then it's best to start off with that, figure out what versions they are available in, and then make the rest of your design from there. Now let me show you a couple examples here in Fusion of some of the keyboards that I've made, and then we'll cover together how to create one, and I'll actually show you step by step, at least the beginning of it, of how you can make that. Then after that, I'll follow up with the different manufacturing methods, and you can use the time codes down below and the chapters to jump between the different things that interest you, of course. So here you can see my steampunk keyboard that I built recently, and the way I constructed this is actually with a brass plate here in the middle where all the keys are inserted through, and then a 3D printed body all around. With everything except the PCB and that key plate hidden, you can see a bit better how it's just this 2mm brass plate where all the switches are inserted into, and then there is the PCB here in the back, and that is how everything is connected. You can also see, if you look here, that here is where the stabilizers would mount, and I will talk more about stabilizers later. The other thing you can see is, since I CNC machined this key plate, there are these little dog bones. You can see it even more clearly if I hide the keyboard, that these are not just square pockets, but they actually have little extra circles here. That's just so you can actually machine it. I will show you how to do that later. Another one is this one I designed for 3D printing. That's for my 10 keyless keyboard that I built. You can see that it's split in half. That's because it needed to fit into my 3D printer. And you can also see here that now we have square cutouts, and once again the cutouts for the stabilizers, but without the dog bones. Here once again the PCB just kind of mounts in there, and on the back there's like a cutout for the USB-C port, and everything should fit in nicely. My most recent keyboard is probably almost the easiest in that regard, since it is just a 9x6 grid of single 1U keys, but I decided to billet machine this from aluminum, as you were probably able to see. So it's not just a key plate with other stuff inserted, but actually this entire part is machined out of a solid block. If I hide the bottom and we look on the inside here, you can see like standoffs. This is where I screwed in the PCB from the back to make everything one rigid unit. And then once again you can see the dog bones here, as this was also CNC machined, of course. These are all for kind of key switches which are mounted through a plate, but if you just have a simple keyboard like the one that we built in the most recent video about advanced electronics, there I just mounted the switches directly to the PCB without a key plate, and then a simple case like that is plenty. The PCB will just sit in here, and there's protection on the bottom so that none of the electronics will touch the desk. And this is screwed in with these little mounting points here, and there's a cutout on the back for the USB port, and this just kind of gives it nice protection all around. And since I added some RGB LEDs in there by 3D printing this out of a clear plastic, I was able to get a nice looking glow everywhere. And this is fairly simple case. I don't really have to show you how you can do this. You can simply import the sizes for your PCB and then go ahead and model that up. You can have a look at my Fusion tutorial series if you're not familiar with it and your problem is knowing how to use Fusion. In this video I cannot focus on that, so I'll just focus on what's specifically interesting for keyboards. So with that, let's go ahead, start a new project here. I'm gonna just start off with a new sketch here on the XY plane. And then actually, before I start sketching anything, I'm gonna go into here, change parameters. If you don't have this up here, you can go down here to modify, change parameters. And if you wanna pin it up here, because you might use it a lot, you can hit the little dots here, then pin to toolbar. What this allows you, it gives you a window here where you can add your own user parameters. Let's first define U. For the units, and as expression I will type in 19 millimeters. And now when we're defining sizes, we can just type in U or 1U or 2U, and it will automatically calculate that from this expression. This just saves us from calculating what 1.25 times 19 millimeters is. Let's add another one for our switch dimension, and basically all mechanical switches that we'll cover here are 14 millimeter. And you might think that you want to modify this one. For example, if your 3D printer is not very accurate, you might have to enlarge it. Now on my Prusa I printed with 14 on the dot, and the switches fit in perfectly. There's no wiggle room, but they also not compress too much. But if you have it defined here as a variable, you can very easily just modify that to 14.1 millimeters if your test print turns out a bit too small. Now you could of course add more parameters in here, but to start out I think this is good. Now, to make our lives a bit easier, let's say that this here is our kind of 0 point and also the 0 point of the PCB, and we'll space all our keys from here. So if you just want to have a simple key, using center point rectangle just makes it easier to dimension in between the keys. You might be used to using the regular rectangles, but if you put in a center point rectangle here, and for the width, we'll do our variable now. And as you can see, once you start typing the variable name, it automatically suggests, and then you can just accept it by hitting enter. And now these widths are fed by the variable, and if we would go ahead and change that, then that would be changed as well. Then let's dimension it from here, and for example, if we go back to this layout here and we want to do this, then this first switch here is 1.25 width. So if it was just one U switch here, then I would space it 1/2 U from the 0 point. Let's say the 0 is here. But since it's 1.25, we'll have to do that accordingly. So I'm gonna hit D for dimension, or you can choose the dimension up here and space it off of the origin, and let's define the height first, since that is easier. That is just U divided by 2, and that automatically feeds from there. And for the size here, it is actually, the expression actually is 1.25 times U divided by 2. Divided by 2 because we want the switch in the middle, and the 1.25 U is just for the entire thing. And then we can hit enter, and this is now positioned according to our little schematic here. Then if we go ahead and put in some more of these switches, I'm just gonna go ahead and copy this one, since that makes it a bit easier. I don't have to dimension it again. I'll just pull it over anywhere for now, and we'll use the dimension tool later to position it exactly. And I'll add a couple here. And then to dimension here, now the distance between center and center will be 1 U. And if we have a look at the layout here, this first key is 2.25 U, so quite large. And then the spacing between these two will be the 1.25 U's, since once again we're going from the center to center. And then here, this next spacing will be different, since we are now going from this 1.25 U key to the 6.25 spacebar. So we need 1/2 of 1.25 plus 1/2 of 6.25. So here you can see 1.25 times U divided by 2 plus 6.25 times U divided by 2. And this now has spaced this perfectly. And here, to keep these at the same height, we can just do a horizontal vertical constraint on the center points. Perfect. And I'm not gonna, for the sake of time, continue with this all the way through, but this is how you would go ahead and design up your keyboard layout. And if you really do it methodical like that, you have a good chance of it fitting perfectly in the end. And if you want to try it out, if you're doing like a standard keyboard layout, just print it out on a piece of paper and hold it up to your keyboard to see if it looks right. Or if you're doing a custom layout, then, well, just pay a bit more attention. Now, the next point that we need to talk about is stabilizers. And there are a lot of different ones. First of all, in case you're not familiar with stabilizers, basically all the keys that are larger than 2 U's, they are so wide that if you just have to switch in the center, for example, for the spacebar, and you press down on one side, you will press down this side, and this it would just tilt, and the other side will go up, and the switch would not be pressed. That would not be a great experience. So instead, what you have is a little mechanical device that makes sure if you press down on one side, it also pulls down the other side and therefore evenly presses down the spacebar no matter where you hit it. Now what this means for us is that we have to integrate those. There are various different kinds. Here is a simple example, and if you ever have taken part of your keyboard, you might have seen something similar. And the main 2 different kinds is either they are mounted to the plate, which is what I've used, like if you mount them to the plate, so you need to have a special cutout of the right shape in your keyboard plate, and then this is where they are mounted. Or alternatively, there are also ones that mount to the PCB itself. In that case, you need to have a cutout in the PCB, and they can either, like these ones here, they have little screw holes, so they are screwed in through the PCB, and that is probably the most rigid way to mount them, and by keyboard enthusiasts often prefer this way. However, there are also ones that just clip into your PCB. They are a bit easier to mount, and you don't have to deal with the screws, but you still need to include that in the PCB. Now, what I've done all of the times is using the plate mount ones, since that means I don't have to worry about the PCB, and I can easily just reprint the 3D print if I mess up the size. And after I've did it once, I knew how to integrate those, so I just kept using them instead of going with the PCB mount. So I will show you in detail how to use these ones, and for the other ones you can go check out some other tutorials, since I cannot definitively tell you how to properly use them, since I've not used them myself. But you can find like footprints online, like this one here for a 2.75 U footprint. I believe this one is for KiCad. I just randomly found this image, and as you can see, here are the holes for the switch, the center hole, the 2 additional holes that are optional, the contacts, and then here are the holes that you would need for the screw-in PCB mount stabilizers. Though which dimensions these need to have exactly, that you should just consult wherever you're buying your stabilizers from. Make sure that they tell you the exact dimensions that you need to include in your PCB. For the plate mount ones, you can find drawings like these ones, and then essentially you just draw it into Fusion and copy all of these measurements exactly. It's a bit of a pain, but once you've drawn it in once, you can simply just copy it, and then you'll be fine. For the spacebar, of course, just this center section here between this one and this one is just enlarged so that the entire thing fits. Here, this center one is the switch, in case that was not obvious. Here we are inside of the sketch, the main sketch for my thank-you-less keyboard. As you can see, I didn't use the center point rectangles on this one, but it was a lot more of a pain to use it, and I now have figured out this trick, so that's what I shared with you. But here you can see, or probably not very easily see, the layout where I've put in all the different sizes. And once again, I've just put in the exact sizes for most of these. And in some cases, I had to use a knife to clean up some small parts, but I find it easier on small details like this to clean it up with a knife than to have it too large and then the thing to be just floppy. And down here is the same thing for the spacebar. Now, I think this is probably enough about the basic layout. If you have any more questions, you can leave them down below, but let's move on to the different ways that you can manufacture your keyboard. Let's start off with 3D printing, since that's the one I have open here, and the thing that is probably the most accessible to everyone. It's actually fairly straightforward. 3D printing these key plates is plenty strong enough, especially if you're using a decent PCB in the back. And like once it's all assembled, this was not really all that floppy. However, there are some tricks to make sure that it does not get too floppy. Now, if you have a look at the back here, now the basic thickness that you want for your key plate is 1.5 millimeters. I might have said 2 millimeters before in the previous video, but 1.5 is actually the standard. So from here down to here measures 1.5 millimeters. And but as you can see, like the structure does not end here. If you're using a metal key plate, then that is plenty thick, and you will not need anymore. But with plastic, I did want to add just some more rigidity. Just it by itself, it feels very flimsy, but once you add in the PCB in the back as well, it does become a lot stronger, but anything you can do to make it even stronger is a good idea. And since this space here in between is not used for the regular keys, I added in some extra meat. You just want to make sure to kind of space out this a little bit so that the key can properly switch into place and there is nothing interfering. I just did like 1.25 millimeters, as you can see here. You do want to, however, make sure to leave the room around the stabilizers, like here, free, so that those can properly click into place. And you also have to consider that there's the wire that goes through here that also needs some space. So make sure you don't add any support there. I've made a mistake before and had to cut it away with a knife later, but that should be fine. You can also add these little standoff pegs here, and the height for them is 2.9 millimeters usually from the back of the thing or from the front of your key plate. The height would be 4.4 millimeters, which is kind of the standard size for those. You, however, don't necessarily need those. Let's just make sure that everything is locked together nicely. Another thing you want to do for better 3D printability is on the front side, since you're probably going to print this with this side flat on the build plate, add a little chamfer. I just did like a 0.5 millimeter chamfer here, and what that makes sure is that you don't have any material squeezing out on the first layer that is going to make the hole smaller. Alternatively, instead of modeling this chamfer in, you can also set your elephant's foot compensation, which is how it's called in Prusa Slice. I believe it's called like first layer expansion compensation or something like that in Cura. And you can just set that to like 0.3 or 0.4 millimeters. And that will essentially add a chamfer on the first layer as well and do the same thing. If you don't do this, it can just happen that you have tiny bit more material, and then even if the width here is only like 13.9 instead of 14, you're already having a bit of a hard time pushing it in, and even though you might be able to push the switch in, it might be pressed on it too much and make it not operate as smoothly. So the best idea is to just do a quick test print of like 1 or 2 switch holes. Try it out if your printer works perfectly, otherwise you can enlarge the holes slightly, but you also don't want them too large since you don't want your switch to flop around, of course. That more or less covers the 3D printing aspect. And when we move over to CNC machining, on the one hand it gets easier because you don't need to worry about the thickness since you're probably using metal, and you also don't have to worry about the chamfer since you're cutting cleanly, but what you do have to worry about is the corners. Unless you are a genius and have somehow found out how to mill a square corner with a round end mill, you will have a radius in the corner. And since the switches don't really have much of a radius, the like corner radius is maybe like 0.1 or 0.2 millimeters, so you would have to use an extremely tiny end mill if you wanted to have the perfect corners for the switch to still fit in. So what is much easier is to add this little extension here called a dog bone. This essentially just makes sure that once the cutter follows through, that the corner here in the end is where the corner of this rectangle would be. And this material here is essentially cut out too much, but it doesn't really matter. You still have a lot of contact area here, and you can't even see this as the switch has a little lip that goes over it anyhow, so you cannot even see this in the end. Here you can kind of see the layout, how I did it. Depending on how small of an end mill you're willing to use, you can change the diameter of this circle. I decided to go really small and use a 1 millimeter end mill. So I decided on a 1.5 millimeter circle. That way the end mill does not like fully engage, which would probably break it. So I just did a 1.5 millimeter circle, and then made this point here, like added a coincident point to the rectangle and clean it up a bit. And then you can simply copy paste this shape all around and when you're using your layout. This will then ensure that your switches fit in the end. Now, if you're laser cutting, you probably don't have to worry about any of this. You just might want to do a test to see if you have like a curve width. So like if your laser is cuts a bit too wide, and to potentially adjust for that. But it should not be necessary to add any dog bones or any other things. But I have not personally tried that. So I hope this helped you out to design your own keyboard enclosure. And if you have any more questions, make sure to ask them down below or suggestions for what I should cover in future videos. Also, make sure you subscribe so you don't miss the last part of this series, where I finally go over the software that you need to power everything and get your keyboard up and running. If you like this video, leave a like down below, make sure to comment, subscribe, all that good stuff, and I'll see you guys next time.